We are going to study about free fall. In this section, we are looking at object that is falling under gravity. So free fall, the idea is an object that is dropped or begins falling and is affected only by gravity is said to be under free fall. So if an object, say a rocket, that's also falling, right? When we have rockets, they can also be falling. But additionally, what do they have? Yes, they have thrusters. So this is not a free fall scenario. So in actual free fall, what happens? We just have the object falling under the influence of gravity. Okay, so the earth, for example, is pulling towards the center. So this is free fall. So as a definition, a free falling object is any object moving freely under the influence of gravity alone, regardless of its initial motion. So someone could have thrown it, someone could have thrown it. Trying to draw a hand. Someone could have thrown it. But after it's thrown, after the object leaves the person's hand, it is said to be under free fall. Object thrown upwards or downwards and those released from rest are all free falling once they are released. Okay, so that's the point I was trying to make. Any free falling object experiences an acceleration directed downwards, regardless of its initial motion. So even though I threw it a bit side, after certain distance that is traveled, it will point towards the center of the gravity. It will fall towards the center of the gravity. But anyways, point is it's always falling. So initially it might look like it's falling in a particular direction, but eventually it will point towards the gravitational force. So there's a lot of factor. We'll be studying this under a different chapter altogether. Now it's just few equations that we're dealing with and few situations. It's not that hard. So these are the things that we need to know. The magnitude of free falling acceleration as a symbol is represented by g. So we'll see what does it mean. The value of g near the Earth's surface decreases with increasing altitude. Further, all of this point we'll understand with time, guys. Further, slight variation in g occurs when changing its latitude. All of this will prove it as well. So graphical view of object under free fall. So let me show that. That is supposed to be Earth. So we have an object. Say I leave it. So what happens? It will start falling in this way. So what is happening? Yes, the object is accelerating because it's covering unequal distance in equal interval of time. And you can see the graph looks like this. So the distance covered keeps increasing this way. Displacement also increases this way. Speed also increases. And acceleration, in our case, we just shown it as 5. So for the sake of, this is all software kind of thing, right? So it's pixel per second square and all of that. So you don't have to worry. But point here is that it's at constant accelerated motion. Okay, so this is a straight line. This is constant. This is increasing linearly. This is not non-linear increase. Okay, so it's an accelerated motion. So we have accelerated time graph, velocity time graph, distance time graph. You guys saw all the three. You need to know this. And again, we'll be applying all of this knowledge soon. So you can pause. And this is a separate chapter wherein we'll study all of this in detail. So this is a simple introduction to this topic.